In this video, I'm going to show you how to do Edexcel A-Level Maths, June 2019, Paper 1, Question 11. My name is Sunil Tanner. I'm a tutor and author. I'm available for one-to-one tuition both online and in person. I live in Buckinghamshire, England. A competitor is running a 20-kilometre race. She runs each of the first 4 kilometres at a steady pace of 6 minutes per kilometre. After the first 4 kilometres, she begins to slow down. In order to estimate her finishing time, the time that she will take to complete each subsequent kilometre is modelled to be 5% greater than the time it took to complete the previous kilometre. Using the model, A. Show that her time to run the first 6 kilometres is estimated to be 36 minutes and 55 seconds. Okay, so for part A, we've got the first 4 kilometres are the 6 minutes each, so 6 plus 6 plus 6 plus 6. The next kilometre is 5% greater than 6, so it will be 6 times 1.05, and the next kilometre will be 6 times 1.05 squared, because it's 5% greater than the previous kilometre. So if we put that into the calculator, this comes out to 36.915 minutes. So obviously we need to convert that into minutes and seconds, so we do 0.915 times 60, which gives us 55 seconds. So the total is 36 minutes, 55 seconds. Okay, part B of the question. Show that her estimated time in minutes to run the rth kilometre for r is between 5 and 20 is given by 6 times 1.05 to the power r minus 4. So what we could do here is look at a little chart of the time. So let's say r is the kilometre and the time for that kilometre. So the 5th kilometre we've already established here is 6 times 1.05, which we could also think of as 6 times 1.05 to the 1, which is of course 6 times 1.05 to the r minus 4. The 6th kilometre, again we worked it out already, was 6 times 1.05 squared, which we can see is 6 times 1.05 to the r minus 4, once again, because of course r is 6 now. 7th kilometre would be 6 times 1.05 cubed, which again is 6 times 1.05 to the r minus 4, etc. I think that would probably be sufficient for part B, since the seeing as it's only 1 mark. And part C, estimate the total time in minutes and seconds that she will take to complete the race. Now what we need to do here is break up the race into 2 stages. First of all, there's the constant time per kilometre at the beginning, and then there is a geometric sequence of times where we multiply by a common ratio of 1.05. Now we could start that at the 5th kilometre, do the constant time as 4 times 6, and then work out the 5th kilometre. Or what we could do is we could use the 4th kilometre as the first term of the geometric sequence, because after that we multiply by 1.05r. So I'm going to do it that way. So what I'm going to say is the total time is equal to 6 plus 6 plus a geometric sequence with the first term of that sequence, or A, would be 6. The common ratio is 1.05, and there are 17 remaining kilometres, so n is 17. So what we're going to do is put that into the formula. So the time is going to be 18 plus, and then using the geometric sequence formula is A, which is 6 times 1 minus r, 1.05 to the power n to the power 17, divided by 1 minus r, 1.05. And if we put that into the calculator, we get 173.0421 minutes. And of course we need to convert that into minutes and seconds. 0.0421 times 60 gives us just over 2.5 seconds, so 3 seconds to the nearest second. So the time is equal to 173 minutes and 3 seconds. And that completes question 11.